Hello students, in this video we are going to see 3 questions from sample papers available on the internet year 2024-25. So let's begin the video with this first question, which is for 1 marks. It's an MCQ. This is for 1 marks. In this question, if median is 137 and mean is 137.05, then we have to find the value of mode. In my previous videos, I have mentioned this empirical formula. So this is the question on this formula, and we have to find mode in this question by using that empirical formula. The formula is mean minus mode is equal to 3 times mean minus median. Either you can use this formula or keep simplifying this to get mode equal to 3 times median minus 2 times mean. So either you remember this or you remember this. In case they are asking mode, this is the formula. We just need to put the values of median and mean. So 3 times this is median minus 2 times this is mean. Usually what you can do, you can multiply these numbers directly and get the answer this. So what I have done here is I have handled this decimal part separately. So 2 times 137. So this 137.05, I have written it like this: 137 plus 0.05. So the remaining is the usual calculation. So I don't want to handle the directly multiplication. I am comfortable with dealing with fractions. You can multiply directly and get this answer. Second MCQ is the circumference of a circle increases from 4 pi to 8 pi. Then what is its area? Means the area is tripled, doubled, or 4 times. This is 4 times, this is 2 times, this is half times, and this is triple, 3 times. So this is the explanation for this circle C1. For its, the circumference is 2 pi r1, which is given 4 pi. From this we can get radius is 2. Hence the area is 4 pi. You just need to put the value of r1 square, 4 pi. Same thing we can do for the another circle, which is bigger in size, because the circumference is increased to 8 pi. This is the circumference. From this we are getting the radius. Radius is 4 and area is 16 pi. Now observe that A2, area 2 for the second circle, area 2 is 16 pi. For this 16 pi, I can write it 4 into 4 pi. Then this 4 pi is my first area. So A2 is equal to 4 times A1. So it's 4 times, quadrupled. Okay, this is the correct option. This is the question for 5 marks. In this question, we have a triangle ABC. AD is a median, which means this point D is a midpoint, O is any point, and OD is equal to DX. These are the targets. EF is parallel to BC. We have to show that this line EF is parallel to BC. And these sides are in proportion. Let's begin the solution. Given AD is a median, which means D is a midpoint. This thing I have written directly in given part, and OD is equal to DX. These are the targets. So for first sub question, let's look at the diagram first. This is the diagram. Now, given that AD is a median, AD is a median, so D is a midpoint, so BD is equal to DC. Observe that BD is equal to DC, we just wrote it right now, and OD is equal to DX is given, this is given, which implies this line segment and this line segment, they are bisecting each other. Whenever the two line segments bisect each other, the endpoints, the four endpoints will form a quadrilateral, and it is a parallelogram. Because for parallelogram, if the parallelogram, diagonals bisect each other. So BC and OS bisects each other, therefore it's a parallelogram. Now BOCX is a parallelogram, so the opposite sides are parallel. So OC is parallel to BX, OB is parallel to CX. This is what I have written over here. BO is parallel to XC and CO is parallel to XB. Now the whole BO is parallel to XC, which means the small segment of BO, this is my BO, and this is the small segment I am talking about. OE is parallel to XC. Similarly, OF is parallel to XB. You can see that in the diagram. OF, this much segment is parallel to this. Okay, now in which triangle we have to go? In triangle ABX. In triangle ABX, this is the miniature of that triangle over here. And we have OF parallel to XB. So by using basic proportionality theorem, we have AF upon FB, AO upon OX. Similarly, in triangle AXC, where is triangle AXC? This side. AXC. Got it? In this triangle, this line is parallel to this base. So in that triangle AXC, we have AO upon OX, AE upon EC. So from 1 and 2, these two things are same, which means this is automatically equal to this. So from 1 and 2, we get this. AF upon FB equal to AE upon EC. So these sides are in proportion. Now we have to see that these four sides are in which triangle? These four sides are in triangle, so AF, FB, AE, EC. They are in this triangle also, in triangle ABC. Okay? So in triangle ABC, we already have this. This time we are going to use converse of BPT. So by using converse of basic proportionality theorem, the EF is parallel to BC. You can see into the diagram, EF is parallel to BC. This is what we want in sub-question 1. Now coming to the second sub-question, just have a look. AO is here, AX is this, AF is this, and AB is this. So obviously we have to go in triangle ABX. So we had already written something about triangle ABX. This is what we had written by its equation 1. So second sub question starts from here. In triangle ABX, we already have 1, we have this. Taking reciprocal of this, AF is in denominator, this, like this. And adding 1 both the side, we get this. This is the LCM. FB upon FB plus AF upon AF is equal to OX plus AO upon AO. Now, FB plus AF, just have a look in the diagram. FB plus AF, are they ready to add with each other? FB and AF. FB and AF. So if I add them, I will get whole AB. Okay, so addition is correct. So FB plus AF. Similarly, OX and AO, they will add and become AX. Again, I have inverted them. So from this, I have taken inversion of this ratio, and this is what we need in second sub-question. That's all in this video. I hope you understood all 3 questions. This is from chapter Triangle for 5 marks in full detailed manner. So deliberately I have taken this empirical formula. This is not in our syllabus, but this doesn't mean that it will not come in board exam. So once the topic is there, anything can be asked in the main exam. We have to be fully prepared. That's all from my side in this video. Thank you, everyone.